Hi, it's Dr. Mamari, and I'm going to perform experiment 2 for chemistry 1032 lab at Central Campus for you to be able to collect the data so you could do the calculation and find the density for liquid, density for unknown liquid, 2 unknown liquids, and density for solid sample. Density is mass per unit volume. The unit for density is gram per milliliter for liquid, gram per cubic centimeter for solid. And the purpose of the experiment today is, as I said, for you to be able to collect data so you could turn in your data sheet as an assignment to your professor. Is that me or someone else? So we talked about the density for definition for density, units for density, if it's liquid or solid. The application for density is that we can find the density. We can, based on the density, we can identify unknown sample. We can also, if we have the density, we find the mass. If we have the density and the volume, we find the mass. If we have density and mass, we can find the volume. Sometimes we have to convert to one or the other physical properties in order to use it. Like if you have a medicine that you don't want to measure the mass, but you're measuring the volume, if you have the density or you have the percentage, it's very, very similar to that. You're using conversions of the density as the conversion factor. So you can change the volume to mass or mass to volume and vice versa. A specific gravity is a ratio of density to the density of water. So at room temperature, if the density of the water is 1 gram per milliliter, and you have the density for your sample, basically what you are doing is just canceling the unit. So numerical value would be similar to the density of the compound, but would be unitless. After this short and brief explanation about the density and specific gravity, you have the pre-lab assignments. Which you will get it as the pre-lab quiz, which you are going to finish and complete it in D12. Then you get the procedure for the experiment. So we're going to follow the procedure for experiment for the liquid. We are going to weigh a beaker with the stopper. So I'm going to stop actually the document so I can use the camera to show you the procedure, to ask you to follow me with the procedure, and I will follow the procedure from the document that I have from the printout to perform. So we are going to measure the mass for empty flask with the stopper. The balance needs to be tiered first. So I tear the balance. I place the flask with the stopper on the scale and measure the mass, which I'm going to record it to you. So for liquid unknown A, liquid unknown A, liquid unknown A, trial 1. Trial 1, mass of empty. Flask with the stopper equals 33.638. Then we need to add 10 milliliter of the unknown liquid A. So I'm going to take this to the fume hood to add 10 milliliter of the unknown. To add the 10 milliliter, exactly 10 milliliter, we're going to use a pipette and pipette pump. We insert the end of the pipette into the pipette pump, and the tip of the pipette is going to be placed inside the unknown liquid in the beaker. Based on the design of this pipette, if you wheel down, you are going to pull the liquid in, and we pull the liquid in until it reaches this brown line, which is called the index line, and adjust it at that line. So I'm going to bring it close so you could see that this is the line. When we fill it up to this line, index line, that means we have exactly 10 milliliter of the liquid. Then I transfer to the flask. I have to put the stopper on because the liquid that we are using is organic liquid, has low boiling point, and if I leave it open, it can vaporize while we are performing the experiment. So we are going to measure the mass again. So the mass this time is going to be the mass of copy paste, so I don't have to stopper plus liquid. Plus liquid equals 41.779 gram. The volume, of course, is 10 milliliter because you already know that it is 10 milliliter. Okay, that is for trial 1, and the rest is calculation for you to perform. So you're going to perform calculation yourself. You're going to take a new sample, a different flask, to measure the mass. This time, the mass equals, this is for the second trial, and second trial, unknown A. Mass of the stopper is 28.925 grams. Plus the liquid, going to get the 10 milliliter of the liquid again. And measure the mass. The flask, both of them are 50 ml flask or 25 ml flask, but the mass is not the same. So it's hard to assume that they are going to be the same mass. So you should always measure the mass actually. Point .043. Okay. For unknown B, For unknown B, gonna have to do a different liquid unknown control. I'm sorry, I am very slow today because I kind of dragged myself to the lab. I was not feeling good, but since I asked them to prepare the equipment for me, I came to the lab. So I'm talking like no energy, but I apologize for that. It's not supposed to be this way. I just don't feel good today. So the second trial, this is the trial 1. Forget about that. Second trial, just unknown 1, trial 1. We can't go back and change it. It's gone, here it's gone. So trial 2. It's 29.709. 709 grams. Mass of the empty flask. We're just going to get the 10 milliliter of the sample. And the two liquids, they look both clear like water, but they're not the same. You might see that they have different density. 10 milliliter of one liquid doesn't weigh as 10 milliliter of the other liquid. Okay. 10 liter, gotta go measure the mass plus liquid equals 42.656 grams. For the second trial, that was a trial 2, so now I have to make it this one trial 1. Mass of the empty flask equals 30.190. Going to bring 10 milliliters of the sample. equals 43.171. Okay, we are done with the density for liquid. Now we're going to measure the density for solid. For specific gravity, also we have these hydrometers here. You can read the number 0.8204A. Specific gravity for B. So I'm basically reading the hydrometer here. You have to let it float. Three, two, five. Okay, 1.34. I can read from here, 1.34. Zero. 1.340. To measure the density for solid, first we are going to measure the mass. It's irregular shape, so we cannot measure the dimensions. We're going to measure the mass. So solid number is 13. It's just showing what number we are using, 13. Mass of solid equals 69.869 grams. Initial volume reading equals 46.0. Final volume reading we first measure the mass because we don't want it to get wet before you measure the mass. Then slowly from the side of the graduate cylinder we are going to slide it down, because if you drop it fast it can break the cylinder or water can splash. It's 70.1. Okay. And the rest would be calculation, which you are going to do it yourself. So it's asking to do two solids. So we are going to do solid number Take another solid right here. Solid number 3. Here, grab a cylinder. The mass of the solid is going to be 44.478 grams. The natural reading is 31.0. We're going to drop the sample in, slide it in, and the number is 35.0. 35.0. Okay, so you find the volume, you have the mass, you divide mass by volume in order to calculate the density for the two unknown solid that you have. I'm sorry, as I said, I wasn't feeling good, so I was very slow motion today. It's not me usually, but at least you have your data, so you can complete your data sheet and turn in as assignment to your professor. Have a great day. I'm going to stop the recording.